learners, you are welcome once again to Eko Learners Support for WAEC and NECO candidates. Once again, I'm Abiona Kamaldin, so I'll be taking you mathematics, and today we'll look at modular arithmetic in continuation of what we did last time.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
So remember that at the last class, we were able to look at few objectives. Number one, we were able to give examples of events that involves modular arithmetic. We were also able to obtain numbers that are congruent to a particular number in that system. Then we were able to perform addition and subtraction in modular arithmetic. So today we'll quickly look at multiplication, division, exponentiation in modular arithmetic. We also look at how we can solve linear problems, linear equation in modular arithmetic. So the first one is multiplication. So the same way addition and subtraction, we carry out addition and subtraction, is the same way we are going to look at multiplication. So here are a few examples of multiplication in modular arithmetic. So evaluate 43 multiplied by 12 in modulo 7. So how do we do that? You remember the last time that we did, we pick individual numbers in that expression. So when you pick individual numbers in that expression, look for their modulo and then multiply. So 43 here, 43 modulo 7 is 1. Okay? So 43 modulo 7. When you divide 43 by 7, what is the remainder? You know the closest multiples of 7 to 43 is 42. So 43 minus 42 is 1. Then 12 modulo 7, what would that be? Divide 12 by 7. What's the remainder? It is 5. Good. Then the next thing is multiply the answers. So 1 times 5 is 5. So that is how you do that. Then the next one is, what's the last digit when 1, 2, 3, 4 is multiplied by 5, 6, 7, 8? What's the last digit? So how do you think of that question? How do you know the last digit in a number? The last digit is usually unit digit. If I need the last digit in 14, for example, last digit in 14, you know, for example, if I have 14, the last digit is 4. So in this case too, the last digit here is 4. The last digit here is what? 8. And when you multiply it out, you also get the last digit. So simply what you just need to do here is, what they are trying to say is the last 123, 1, 2, 3, 4. It's the same thing as saying 1, 2, 3, 4 modulo 10. You know, when you divide it by 10, or when you divide it, so the last digit will be the remainder. So the unit digit is always what? The last digit. The same thing here, multiply by 5, 6, 7, 8. Modulo 10. So that is another way of writing the question. Alright? So what do we do? The last digit here is 4. So it's like 4 modulo 10 multiplied by what? 8 modulo 10. Modulo 8. Sorry? Modulo 10. Sorry for that. This is 10. This is 10. Modulo 10. Okay. So 4 times 8 is what? 32. 32 modulo 10. But we are asking, we need the last digit. So the last digit, which is also 32 modulo 10, which is what? 2. So the answer to that is 2. All right? So that is multiplication. So you can always find the modulo of each number or element in that expression, then you multiply. Okay, so in exponentiation too, we have this 3 raised to power 16 modulo 4. How do we do that? We also realize that exponentiation is a circle. It gives results that are circular in nature. So what you do here, you don't need to do the multiplication or do the calculation. We just need the last digit. How do we do that? Yes. Now, let's test something. Try and see the circle of powers of 3. All right. So let's try that. 3 raised to power 1 modulo 4. We realize that they are circular. The results are circular in nature. So 3 raised to power 1 modulo 4 is 3. 3 raised to power 2 modulo 4. 3 raised to power 2 is what? 3 raised to power 2 is 9 modulo 4. Modulo 4. So 9 divided by 4, what's the remainder? It is 1. Okay? 3 raised to power 3 modulo 4. 3 raised to power 3 is 27. But modulo 4. Modulo 4 is what? That's 27 divided by 4. And that will give a remainder of 3. So you can see we are coming back to 3. Let's do the next one before we conclude. 3 raised to power 4 modulo 4. Okay, so 3 raised to power 4 is 81. 81 modulo 4 is what? Is 1. Thank you. So you can see 3, 1, 3, 1. That's how the answer will continue to be. Is circular. We are coming back to it. You see, the first one is 3, the second one is 1. You go back again, 3, 1, 3, 1, 3, 1, 3. So it's circular in nature. So that's what we mean by modular arithmetics. So want to see when is the result 3 and when is the result 1. We also need to get that. Especially they test that in the Olympiad exams. So or in JAMB. Alright, so in this case, we have 3 raised to power 1 modulo. So anytime the power is odd, the result is 3. Anytime the power is what? Even, the result is 1. Does it work here? Yes. It works here too. This is odd power, we have 3. Even power, we have what? 1. So what is this? Is this odd power or even power? It is even power. So for even power, what do we have? So the result here is 1. So that is an example of how do we exponentiate in what? In modular arithmetics. Okay, let's see another question. So what is the remainder when 2 raised to power 123 is divided by 7? 2 raised to power 123 is divided by 7. Okay, so you also try to observe that too. 2 raised to power 1. What is 2 raised to power 1 modulo 7? 2 raised to power 1 modulo 7 is what? Is 2. 2 raised to power 2 modulo 7 is what? Is also 4. 2 raised to power 3 modulo 7. That's 8. That will give us 1. Yes. Then these are the circle. So 2 raised to power 4 modulo 7. This is 16. So, and that should give us 2. So you can see we are going back. We are going back. So that's another circle. Now, how do you know? So this is when it is raised to power 1. So we can say here the circle is multiple of 3 after every 3. After every 3. The other one we did was circle of 2. So this is circle of 3 after every 3. So anytime we see the power is a multiple of 3, the result will be 1. If there is a remainder of 1, the answer will be what? 2. If there is a remainder of 2, it will be what? 4. So let's pick this. 1, 2, 3. Is it a multiple of 3? Yes. 1, 2, 3. From our divisibility rule. 1, 2, 3 is a multiple of 3. So hence, 2 raised to power 123 divided by 7. That is modulo 7. What will be the remainder? The remainder will be 1. So that is exponentiation. So quickly we go to division. So division what is very important in division is what? The dividend. This is the dividend and this is the divisor. So you make sure that the divisor is always divisible, the dividend is always divisible by the divisor. So here, 2 is not divisible by 3. So you look for all other what? All other congruent numbers to 2. You know, 2, when you add 5 to it, we have 7. 7 also belongs to the same class with 2. The same thing, when you add 5 to 12 to 7, we have 12. When you add 5 to 12, you have what? 17, and so on. So which one will be divisible by 3? Let's see that. 2 is not divisible by 3, 7 is not divisible by 3, but 12 is divisible by 3. Good. So from that, you say 2 divided by 3 is same thing as 12 divided by 3 modulo 5. So, and that is what? 4. So the result is 4 modulo 5. I hope you get that. Yes. So anything at all you need to divide, you make sure that the dividend is what? Is divisible by this. And if it is not divisible, you continue to add multiples of the modulo. Alright, so lastly, we will now look at how we can solve problems, linear equations in modular arithmetics. Now, we have learned division, we have learned multiplication, we have also learned addition and subtraction. So let's see how we can apply that. So the first question, we have x plus 1 is congruent. You remember this? X plus 1 is not equal to, is congruent. Is congruent to 4 modulo 5. So how do we solve this? The normal way you solve your linear equation. So what do we do? X is congruent to 4 minus 1 modulo 5. So x is what? Equals to 3 modulo 5. So this is the simplest answer. This is not the only answer, but this is the what? Simplest answer. So all other answers could be s is congruent. Sorry, s is congruent to 3. And that's why this is not the. So the answers could be s equals to 3. You add 5 to it, 8. All the classes of 3 are the what? Solution to the equation. So sometimes they request for the least answer, the least value. So this is yes, add 8 to it, add 5 to it, 13, and so on and so forth. So these are the solution to that particular one. You could also have another question like this: 3x plus 1 equals to 2 modulo 5. Modulo 5. So let's see how we want to do this. So we do it the normal way we solve equation. 3x equals to 2 minus 1 modulo 5. I hope you are getting that. Okay. So 3x, sorry, congruent. 3x is congruent to 1 modulo 5. Then what do we do? Yes, the next thing here is what? Divide both sides by 3. You know, we have learned division. Do you remember? Yes. So divide both sides by 3. But you can see that this dividend here, 1, is not divisible by 3. So what do? You look for all other members of the class that is divisible by 3. Now, the first member after 1 is 1 plus 5, 6. You see here that is divisible. Mod 5. So then you can divide both sides by 3. So divide, we have x is equivalent, is congruent to 2 modulo 5. So it means we have our answers to be 2 congruent classes of 2. So it could be 2, it could be plus, add 5 to it, it could be what? 7, it could be add 5 to it, 12, and so on and so forth. So these are the solutions. So sometimes they request for answers between 10 and 20. So if it is 10 and 20, between 10 and 20, it means we are picking 12. So that is how we can approach questions that deals with linear equation under modular arithmetic. So now let's go to our practice question. Yes, I have these questions. In what modulus is it true that 9 plus 8 equals to 5? In what modulus will that be? Then evaluate 23 multiplied by 54 modulo 7. Then the third question is, if 7 plus y equals to 4 modulo 8, find the least value of y between 10 and 30. So you have just 30 seconds. Welcome, learners. I hope you enjoyed the questions. Yes. Oh, that's great. It's fantastic. All right, so let's look at the questions together. The first one, in what modulus is it true that 9 plus 8 equals 5? Yes. Now, let's look at it. 9 plus 8. Actually, 9 plus 8 should be what? Should be 17. Thank you. 9 plus 8 is 17. But now, they are giving us that 17 and 5 belongs to the same congruent class. So, how come it is? So, what you just need to do is like 17 minus 5 is what? It's 12. So, it means we have subtracted, we have divided 17 by 12, and the remainder is 5. So for this to be what? To be correct, it means it must be in modulo 12. And that is why it should be 9 plus 8 is 17. 17 divided by 12, it should be what? 1 remainder 5. So that is just what we need. So the correct answer to that is in modulo 12. All right, thank you. So let's look at the second question. So 23 multiplied by 54 modulo 7. 23 multiplied by 54 modulo 7. Yes. Let's see how we can do that. 23, you do it individually. 23 modulo 7. So if I divide, you know, the closest multiple of 7 is 21 to that. So 23 minus 21 is 2. Good. Okay. So go for the next one, 54. 54. All right. Now look at 54. I'm sure that we all know that 54 multiples of 7. 56, 7 times 8 is 56, but 56 is more. You get it? It is more. So you can do it like that too, but in that case it will be 54 minus 56. That's minus 2. And minus 2 plus 7 is 5. So you can have it like that, or you look for a lower one, that is 48. 7 times 7 is 49. 54 minus 49. 54 minus 49 will give us what? That's modulo 7. So 54 minus 49 is 5. So that is 5. Then we can now multiply. 2 times 5. Modulo 7. 2 times 5 is what? Is 10. So 10 modulo 7. And what is 10 modulo 7? That is 3. So the final, did you get that? Wow, bravo, thank you. That's nice. So the answer, correct answer to that is 3. Now let's look at the last question. It says, if 7 plus y is congruent to 4 modulo 8, find the least value of y. Find the least value of y. For y is between 10 and 30. For y is between 10 and 30. Okay, so let's do that. Okay, it's just normal, the simple equation. 7 plus y is congruent to 4 modulo 8. All right, so we solve that. We have y is congruent to 4 minus 7 r modulo 8. Okay, so and y is congruent to what? Minus 3 modulo 8. Okay, so you know it's just minus 3, class of minus 3. So let's look for some members of that particular class. Okay, how do we get the members? Add 8. So apart from minus 3, we also have what? Minus 3 plus 8 is what? 5. 5 is a member of that class. Add 8 to 5, that is what? 13. 13 is a member of that class. Add another one. If you add 8, that's 21. Add 8, 29, and so on. But the question is, find the least value of y between what? 10 and 30. Between 10 and 30. So this is not between 10 and 30. This is not between 10 and 30. But these are between 10 and 30. And we are asked to find the least of the values. So what is the least? Good, 13. So the least of the values is 13. So that is a solution to the practice questions. I hope you get them well.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
So for comments, questions, and observations, so you can always contact us on our social media handles displayed on the screen. Thank you.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.